Welcome to the series of lectures on C language. This is Saikiran, Assistant Professor from Department of Computer Science and Technology from Madanapalle Institute of Science and Technology. So in our today's lecture, we will discuss about variables and data types. So coming to the content and flow presentation, first we will discuss about what is a variable and we will discuss about how to declare a variable and then how to initialize a variable. Then we will continue with the data type topic. So what is a variable? So generally, the variables are the names which are associated with the memory location. So in this variable, we are going to store some data, and this data will be somewhere in the in the particular memory, right? It will have some address. So to refer that address, we are going to using these variables. So which are nothing but the names. So here to store different types of data, we are going to using the variables, and the size of the variable depends upon what type of data we have been stored. That's why when you are going to declaring a variable, we need to specify the type of the data also, like which we are going to discuss in the uh, like uh, upcoming in this particular lecture. So here we are going to having different types of variables which is going to be depends upon the scope, storage class, lifetime and the type of data that we are going to store. So now we will discuss about what do you mean by scope, what are the different storage classes that we are having in the C language, everything we will discuss now. So here coming to the storage classes are going to specify where actually the data is going to be stored in our system. So here we are having four storage classes in our C language. First one is automatic and second one is external, third one is static and fourth one is register. To represent these storage classes, we are having the specific keywords. They are to represent the automatic storage class, we are having the auto keyword. To represent the external storage class, we are having the keyword extern. To represent the static storage class, we are having the keyword static. And for register storage class, we are having the register keyword. So coming to the automatic storage class, when you are declaring any variable with automatic storage class, then the memory will be allocated for the particular variable is in RAM, and the default value that is going to have by the variable is the garbage value. And this particular variable which you declared by using the automatic storage class will have the local scope. Local scope is nothing but where we are able to access within the block. And second storage class is external. So here when you declare any variable with external storage class, then the memory will be allocated in the RAM and the default value is going to be 0, and the external variable will have the global scope, means which we are able to access throughout the program, not only into the specific function. It can be accessed throughout the program. Like if you are having the 4 functions, the same variable we are able to access into all 4 functions. And next one is static storage class. If I declare any variable with a static storage class, the memory will be allocated in RAM and the default value will be 0, and it is also going to have the local scope. And next one is register storage class. The variable which we declared by using the register storage class, the memory will be allocated in the registers, and it is going to have the garbage value, and it is also going to have the local scope. Now coming to the syntax for declaring a variable. When you are going to declaring a variable, first we need to specify the data type and then variable name and then the value what you are going to assign. Same thing you can give it here itself. So let me take one example here. For example, I want to declare a variable which is going to read the integer type of data. Then the syntax will be like this. So we need to specify the what type of data we are going to store in a variable. So here I want to store the integer data. That's why I am taking the int data type. Don't bother about this data type. Anyway, we are going to studying about this data type full-fledgedly in upcoming lecture. So int space, we need to give the variable name. I am giving the variable name like num. If you want, you can directly give the value by giving the assignment operator like equal. So this is the way how we are able to declare variable. This is the one way. Otherwise, you can declare a variable like this int num semicolon. Okay. And then if you want to assign the value, you can assign the value later. This is one syntax which we are having for declaring the variable. So here If you want to declare multiple variables at a time, which is of same type, then we can have this syntax. We can have the data type, and then whatever the variables you want to specify, it depends upon how many numbers you want to read. All variable names we can give separated with commas. At the end, we need to give the semicolon. So let me take one more example here. Int. Suppose I want to read three different numbers, then we can follow this syntax. Why? Because all we are going to read number type only. That's why we can use this follow, like we can follow this particular syntax. Int num1 comma num2 comma num3. So this is the way how we are able to declare multiple variables at a time. So here I have given the detailed description, like data type specifies what type of data that a variable can store, and variable name of the variable given by the user, and the value, so the particular value which we are going to assign into the variable. So here the variable can be initialized in two different ways. One is static way and another one is dynamic way. So static way we can also call it as a compile time initialization. So where the value will be assigned to the variable during the compilation process. And the second way is dynamic way. It is also called as runtime initialization. Here the value will be initialized to a variable during the runtime from the output console, which we are going to entering through the keyboard. Now we will see the one example program to illustrate how the variable can be initialized during the compile time as well as runtime with the help of one example program. Here uh, I'm going to using the Ubuntu application to write my C programs by using the VI editor. So VI demo2.c I'm taking. So now here I am going to write in the program. So in our earlier lectures, we already discussed the structure of C program that we need to follow when you are going to writing the C program. So let me write the header file first. Hash include dot h. So I am taking the main as void. Anyway, we'll discuss about what is this main and like void and all in our upcoming lectures. I am taking one variable a, and to that variable I am going to assigning the value 10, and I am going to printing the value of the variable d comma a. So don't bother about this printer %ld and all. In detail, we are going to discussing about all these things. So what is this %ld? Why we need to use? How the printf can be used to display something on the screen? Everything we will discuss one by one in our upcoming lectures. Now, this particular example is going to illustrating how a variable can be initialized in static way. Let me compile the code. GCC space demo2.c. Now my code is compiled successfully. Let me run it. /a.out. Now here you can see the value 10, right? So this is the value which I have given to the variable a, which I am displaying here. Now we will see the example, like how the value can be initialized in dynamic way. In order to initialize a variable in dynamic way at runtime, so we should use the scanf function. So as I told you, like we will discuss about all these scanf functions and all in our upcoming lectures. So when you want to initialize a variable in dynamic way, just we need to declare the variable. Let me write some predefined statements like enter a number for our output representation purpose. I am using the scanf function, scanf %ld comma ampersand a. So then let me print the value of a here. Printf %ld comma a. So this is the example program how a variable can be initialized in dynamic way. Demo2 dot, sorry, demo2 dot c. Now my code is compiled successfully. Let me run it. Now it is asking me to enter a number. I'm giving the value 20, and whatever the value I enter, I am able to display. So this variable, like this value 20, is assigned to the variable a, and which I am displaying here. Clear? So these are the two ways how we are able to initialize a variable. Now before going to the data types, let me discuss like one more topic. Like we discussed something like a variable is a name which is associated with a memory location, right? Now when you are going to give the name to a variable, we need to follow certain rules and regulations. So in our regular lecture, we already discussed about the identifier rules, right? Same rules will be applied here for variable also. So anyway, let me discuss it one more time. So here, like rules rules to give name to a variable. So here the first rule is a variable name can be a combination of alphabets, digits, and a symbol underscore. So it can be a combination of alphabets, digits, and underscore symbol. And second one is a name cannot start with a digit. Cannot start with a digit. And third one is a name can start with alphabet as well as underscore. Name can start with alphabet and underscore. And fourth one, we cannot give any space in the middle of the name. Cannot give in the middle of the name. And fifth one, all variable names should be unique in a single program. So names should be unique, and all the names are here case sensitive. Why? Because C language is a case sensitive. So small letters and capital letter both are treated as different. So that's why here names are case sensitive. And keywords cannot be used as a variable name. Cannot be used as variable name. So these are the rules which we need to follow when you are going to give the variable names. Now we will move to our next topic, which is data type. So at the time of variable declaration, we have seen like when you are going to declaring a variable, we need to specify the data type that we are going to store inside a variable, right? So from that we can take the definition of a data type. A data type specifies the type of data that we are going to store in a variable. So here each data type requires different amount of memory and has specific operation that can be performed over it. In C language, the data types are categorized into three categories. First one is primary data types, and second one is derived, and third one is user defined data types. So here you can observe, under primary we are going to have in the data types like void, integer, character, double, and floating point data type. Under derived data types we are having like arrays, references, as well as pointers. And is coming to the user defined data types, we are having the structure, union, and enumeration data type. So here basically first we are going to discuss about the all these primary data types, and these arrays, pointers, structures, unions we are going to see in the upcoming lectures as a separate chapters. Now we'll discuss about the primary data types. So here, what do you mean by primary data type? So these primary data types, we can also call them as predefined data types, which are given by the language developers. So as these are the predefined data types, we cannot modify them. So we need to use them as they are available. So here under primary data types, we are having something like integer data type, and second one is floating point data type, character data type, and last one is double. And apart from these four, we are having one more thing like void. So basically this void we are going to using along with the functions. We never going to using with the variable. Void means it doesn't return any value. Now we'll discuss about these four data types in detail, like how much memory they are going to occupy, and what is the format specifier or control string we are going to use in order to represent the particular data type. Everything we will see now. Here we can see like which data type occupying how much of memory and what is the range of value that we can give to a variable. So when you are declaring the variable with a specific data type. So here when you are coming to the character data type, the keyword what we are going to use to represent the character data type is char. Basically it is going to take 1 byte of memory, and which is nothing but 8 bits, and the range of values that we can store inside a character data type is minus 128 to 127. Suppose if you are using the unsigned char data type, then it is also going to occupy in the 1 byte of memory, and the range of values will be from 0 to 255. So when you are going to using the normal integer data type, the keyword which we are going to use is int, and it is going to occupying 2 bytes of memory, and the range of values will be minus 2415 to 2415 minus 1. And when you are using the unsigned int, it is going to occupying 2 bytes of memory only, and the range of value will be from 0 to 2 power 16 minus 1. And when you're using the short int, it is going to occupying 1 byte of memory, and the range of value will be from minus 128 to 127. And when you're using the unsigned short integer, it is also going to occupying only 1 byte of memory, and the value range will be from 0 to 255. For long int, the keyword will be like long int, and it is going to occupying 4 bytes of memory, and the range of values will be from minus 2 power 31 to 2 power 31 minus 1. For unsigned long int, it is going to occupying 4 bytes of memory, and the range of values will be from 0 to 2 power 32 minus 1. So to represent the decimal numbers with the numbers with point values, we are going to use in the floating point data type, which is going to occupying 4 bytes of memory, and the value range from 3.4e minus 38 to 3.4e plus 38. And double data type, the keyword will be double only, and it is going to occupying 8 bytes of memory, and the range of values will be from 1.7e minus 308 to 1.7e plus 308. And for long double, it is which is going to occupying the 10 bytes of memory, and the range of values will be from 3.4 e minus 4932 to 1.1 e plus 4932. So these are the different data types and how much memory they are going to occupying and the range of values. Now we will discuss about the format specifiers which we are going to use to represent the data type. So here for signed integer we are going to use the format specifier %d, and I have given an example also. The example value will be like 76. Here signed decimal integer we can represent by using %i. For unsigned octal integer we are going to using %o. %u can be used for unsigned decimal integer, and %x we are going to using for unsigned hexadecimal, and %X will be used for unsigned hexadecimal with the help of capital letter, and %f is used for integer including the decimal point, which is nothing but a floating point number, and %e is for signed floating point, and %E is for signed floating point using the capital letter, and %g is for the shorter between the %lf and %e, and %G is for the shorter between %lf and %E, and %x is for character and %s for string. Actually this is %c, not %x. We can use the %c for representing the character data type. So here these format specifiers are going to specify what type of value we are able to access when you are trying to print the value as well as when you are trying to read the value from the keyboard. That time we are going to using this format specifiers. We can also call them as control string. So this is about data types. So here let me take one example. I will declare some variables with different data types. We will assign some value to them and we will try to print the values of the particular variable. Hash include. Let me declare the variable, like I'm declaring one variable int num. Like this num variable is going to take the integer type of data. Let me take one more variable float. Let me take the variable like num2. So this variable is going to read the uh, floating point data. So let me initialize the values here. So let me take the variable like num equal to 10 and num2 equal to, let me take some value like 10.65. Let me print the values of num and num2. Printf. So as I am trying to display the value of the integer variable, so I should use the format specifier %d, comma, the variable I am going to call here num. So \n, we already seen the under constants, a single character constant. So \n is going to take you to the new line. Num2. Variable dot. Okay. Now you can see like what is the mistake I have done here. So here I declare this particular num2 as floating point, but I am using the %ld. So that's the error what I got here. So let me change it to %. F here. Now it is executed successfully, compiled successfully. Let me run it. You can see the value. Here you can observe one thing, right? So here when I'm trying to print the floating point value, I got like 10.650000. But actual value what I given here is, you can see here. But the actual I given only 10.65. But when I'm trying to get the output, what I got here 10.650000. I will tell you why it is coming like that. So here when you are trying to read the floating point number, by default it will take 6 digits. 6 digits after the present point, means after point it will take 6 digits. As a given only 10.65, when you're trying to print the value, we are going to get the 6 digits and all the remaining digits are going to fill with zeros only. And you can see like this floating point data type and double data type, which both are going to be using for representing the floating point numbers only, right? But what is the difference means, here you can see, if after point if you want to get up to 6 digits, then the data type you can use it as floating point. If you want to get more than 6 digits, then we can use the double data type. So after operation means after point we can get more than 6 digits. Okay, so this is about the data types. So these are the references which I have considered. You can go through these references and you can get the clarity if you are having any doubts. And if you are having any queries or questions about this e-content or PPT presentations, kindly leave your queries here. Here I am sharing the Google form link here. Thank you.